Hi, sixth grade. Here are your review notes for the upcoming solar system quiz. We'll first go over this Earth, Moon, and Sun notes that we took quite a while back, actually. We'll look at these three things. Then we'll quickly kind of go over the specific planet notes that you all shared, as well as that last little bit that had to do with the order of the planets in the solar system, as well as what makes a planet a planet. This was the first set of notes that we had, having to do with the Earth, the Moon, and the Sun. And the first is that this idea that gravity moves things in our solar system. The more massive, the more big an object is, the more gravity it creates, and that gravity allows other things to orbit around them. And that's why the planets orbit the sun, and that moons can orbit planets, and all those things spin around due to the pull of gravity. But when we look back in the thinking of how these things were all arranged, the model of how the Earth and the Moon and the Sun were put together weren't always consistent. So a long time ago, the thought was that it was the Earth was the center of the solar system, in fact, the universe, and that was called a geocentric model. And the thing about this model was that though we put the Earth in the middle there, when you looked at things crossing the night sky, they didn't seem to circle Earth very well. They seemed to sort of move in these strange, sort of wandering, reverse sort of loops as they crossed the sky. And so even though how could the Earth not be the center of the universe? The movement of things around the Earth seemed to not fit very well. And it wasn't until 1543 that Nicholas Copernicus had a new idea. He said, wait a minute, what if the sun were the center of the solar system and that the Earth and the other planets revolve around the sun? And this was a new, brilliant idea. It had a lot of elegance to it. It seemed to fit quite well, but there was no proof. The proof came until Galileo Galilei had used a telescope and he looked at the moons of Jupiter, just like you looked at the moons of Jupiter during the star party. And he noticed those moons of Jupiter orbited Jupiter itself. It went around the planet. And he thought, well, wait a minute, if smaller objects can go around a larger object, why can't things like planets go around the sun? It doesn't necessarily mean that everything is going around the Earth. If moons can go around a planet, perhaps planets can go around the sun. He also noticed that Venus has phases, like our moon has phases, a full moon, a new moon. Venus too has sometimes a half Venus, a crescent Venus. And this put this idea that, if the sun were the center of the solar system, this all makes sense a little bit more. Now, they didn't like this idea. This is called a heliocentric. Helio meaning the sun, a sun-centric, because it kind of put the position of the Earth, well, essentially not in the center. And people didn't like that, okay? So, now today, we all know that the sun indeed is the center of our solar system and that the Earth revolves around the sun. And in fact, not only does it revolve around the sun, the Earth spins during its revolution. Now, those are two important terms. A revolution is what we call a year, the time it takes for a planet to go around the sun. Different planets, depending how far away they are from the sun, have different time lengths of their year. A day, as we think of it, is the time of the rotation. How fast does it take for the planet to spin on its axes? So for Earth, our year, the time it takes for the Earth to go around the sun, is 365 days and a little more. That's why we have leap year every 4 years. And our rotation, our day, is 24 hours. So it takes 24 hours for the Earth to spin once on its axis. And it takes 365 days, or 365 spins, to make it all the way around the sun. Another thing to think about, and this is important for seasons, is that the tilt of our spinning Earth, the axis is tilted a little bit. And this is important because when the sun strikes the Earth, it does so in different ways. And this is why we have the seasons. It's not because the sun is closer, or I'm sorry, not because the Earth is closer to the sun in the winter. It's not because of that. In fact, during the winter, we're actually closer to the sun in the northern hemisphere than we are in the summer. It has to do with how the sunlight directly or indirectly hits the Earth. In the summer, the Earth, the northern hemisphere, is tilted towards the sun, so more light is hitting, bam, 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 the northern hemisphere directly. Less is hitting the southern hemisphere directly. That's why it's warmer, summertime, in the northern hemisphere in the summer. Reversely, in the winter, the Earth's axis in the northern hemisphere is tilted away. It's tilted away so that less light, less energy hits the northern hemisphere directly, so it gets cooler. More sun energy directly hits the northern hemisphere in the summer and vice versa. That's why in Australia, in the southern hemisphere, their seasons are the opposite of ours. You can also think about how the Earth spins on its axis, because right above the spinning Earth, right above us, is Polaris, a North Star. It's actually two stars, as we learned from the Star Party. And that everything, as we spin underneath the North Star, all the things in the night sky spin around it as well. Here's a picture of that. Here's the North Star, and with a camera that was exposed over time to show the movement of the stars around it, can show how everything spins around the North Star due to the fact that the Earth is spinning. Okay, let's not worry about this one here, the moving of the equinoxes. Back to rotation revolution. This now leads into the moon. Now the moon's rotation the moon's revolution, how long it takes to go around the Earth, is about 29 and a half days. It also takes about 29 and a half days for it to spin. And because its revolution is the same as its rotation, as it goes around, the same side of the moon is always facing Earth because of the similar timing of its revolution and its rotation. This side that we always see is called the near side, and the side we don't see is called the far side of the moon. That's the moon that's away, that's the side of the moon that's away from the Earth as it orbits and goes around us. Okay, eclipses. You guys are experts on eclipses. A lunar eclipse is when the shadow, in the alignment of the sun, the earth, and the moon, the shadow of the earth falls onto the moon and the moon becomes dark. It happens during a full moon because just before it moves into the shadow, it's completely lit up by the sun until it moves into place. Then you would have a lunar eclipse. Reversely, a solar eclipse is when the shadow of when the shadow of the moon falls on the earth. And this also happens in a new moon because the moon is mostly dark, it's in a shadow until it moves right in front, and the shadow then falls on the earth itself. So it's near a new moon. During a new moon is when a solar eclipse can occur. Check that out. There is an actual shadow of an eclipse over the earth, which is pretty neat. Now, these don't happen that often because the angle, the orbit of the moon around the earth is not exactly parallel with the orbit of the Earth around the sun. So they don't line up too often. That makes having a solar eclipse and a lunar eclipse somewhat rare. Luckily, though, in a couple of years, there'll be a big one in the United States, which is pretty neat. Okay, last couple things. Well, here it is again, this idea that the tilt of the moon's orbit is not the same as the Earth. That's okay. All right, here's the last one. Here it comes, 2017. There will be an eclipse in Kentucky. That was Ella Science and News. It's totally awesome. Okay. Oh, and here's another one. Eclipses in other places. In fact, there's the moon of Jupiter, and there is its shadow on the surface of Jupiter. That's like a Jupiter eclipse, an Io eclipse. Okay, now, next set of notes are your planet notes. Now, I'm not going to go through all of these, but remember for the quiz, you need to know the basic information about the planets. You need to know the difference between the inner rocky planets and the outer gassy planets. You do not need to know any specific numbers, but you should know relative amounts. Which planets are bigger than the other planets? Which planets are warmer than the other planets? Which planets have thick atmospheres? Which planets have thin atmospheres? And some major unique information about each planet. For instance, which planet has the big red spot? Which planet is mostly red? Which planet has rings? Which planet has its axis tilted on its side? Those are some of the major distinction characteristics of each planet, but look through these notes to get those from there. I'm not going to go through all of them. You have them right there. And the last little bit is this here, the order of the planets. You will need to know the order of the planets, the location of Ceres, a dwarf planet in the asteroid belt, as well as the location of Pluto, a dwarf planet in the Kuiper belt. You can think of whatever mnemonic you want to keep these in line. My very educated mother just served us 9 pizzas. You can think of it that way, or come up with your own. And the last thing to keep in mind about the quiz, what makes planet a planet? A planet must be a planet, or will be a planet, if it orbits the sun, but most things, a lot of things in the solar system orbit the sun. It must be round. Okay, well, there are things like Ceres and Pluto. Those are also round. And when it's round, it's big enough to create its own sort of sphere. But the last thing it needs to be is it has to be big enough that it has cleaned out its orbit around the sun. And this is where Ceres and Pluto fall off into the dwarf category. Ceres has not cleaned out its orbit. There's still asteroids all around it. These planets have. These planets have. Pluto as well. Pluto is not big enough. It has not cleaned up its orbit around the sun. There are still other dwarf planets around there. So the fact that these exist in this sort of messy belt of material makes them dwarf planets. Not true planets. The true 8 planets are these 4 inner planets and these 4 outer gassy planets. Inner terrestrial rocky planets, outer gassy giant planets. Okay, that's it. Email me questions. See you later.